Today's date is the 23rd of April, 2026. The time now is 5:34 p.m. I'm just gonna talk about the NSIGII Verify. NSIGII is spelled N for November, S for Sarah, I for Indigo, uh, G for Gold, I for India, I for India. Is a humanitarian human rights protocol for delivering food, water, and shelter. I'm going to be explaining how the NSIGII Verify works because it's a real-time encoding system via a linkable then executable file format. Linkable first, only first executable is a core principle of NSIGII. Linkable means you can link the artifact via a linker. Now, linkers are things that associate file names of code files with artifacts. The NSIGII codec, N for number, S for Sarah, I for Indigo, G for Gold, I for India, I for India, is a coder and decoder on the on the fly verification. The term linkable is used to describe how the linker performs an operation whilst executing. Linkable then execution. Linkable file format, then execution as for delivery system. Example: if you have a local minimum, which is an edge, so you have a topology, that has an edge-based topology. You have a peer-to-peer network. Our real-time verification frame. NSIGII is meant to take a drone or any kind of robotics in system and verify it's on the time verification via on the fly verification. So, example, if you have a drone moving at an interval in time, that drone or a robot moving at any interval in time, you know where that robot is position and a position and a position and a location. But the timestamp on the date and the timestamp shows that the drone is correctly in the position at this time and space. NSIGII operates in two-star. It basically uses Dijkstra's algorithm for closest historicity and A-star algorithm for degree of centrality. Dijkstra's algorithm maps up to topography, taking what's nearest to the checkpoint or delivery. So you have a peer-to-peer-to-peer network that can be mapped onto that is a location in space and time. The peer-to-peer-to-peer model is a triangular cluster that verifies the robot was here and now, there and there, and when and where in space-time. It's a GPS system. It's a global position system. The models rotation, reflection, rotation, reflection, uh, 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 rotation, reflection, translation, and rotation, rotation, reflection, translation, and enlargement as an asymmetric translation, rotation, enlargement, translation, reflection, enlargement, and transformation, which is a four transformation, and symmetry as four type of enlargement, like a four type of gyroscopic movement that has some weight. For example, a drone can carry its own weight. A drone of 80, 100 grams can carry a weight of carrying a weight of 80 grams is an asymmetric system that has to recalculate its trajectory, its resources as it flies, as it takes off via an A star Earth curvature. Primarily, I'm trying to design via ontological Bayesian intelligence. Ontological means the system knows itself. Bayesian means it's probabilistic, and intelligence, OBI intelligence, as a principle of cognition, the ability to act um, whilst on the move. The A-star algorithm is the shortest path between 2 points on a surface. So the system takes a curved trajectory as it flies over to deliver food, water, and shelter, or humanitarian aid. Humanitarian aid every day, um, without getting bogged down by ambiguity in the data set. Um, NSIGII, so for example, if a robot's moving across a plane, it knows its position here and now. It doesn't have to calibrate it again to do it again. But basically, system knows its state, the time, and can check the time is without having any overhead in the system via ontological Bayesian intelligence. Means that which ontological means based on probability, of the probabilistic nature of the Earth. The goal is to model this as a calibrate once system, only once, only first once system in time. Because food, water, and shelter should always arrive in time. In time, and time is a composition model called delta t via the b squared minus 4ac quadratic framework of verification, where minus 1, 0, and 1 are trinary state logic of a real-time verification. It's also bound to like the sorry. Also, you have a Cloudflare's system, but now I'll try to show you how to. So you have what am I saying? Cloudflare's system, which is a random generation of the Cloudflare lava lamps, which were used to generate random series of number, but they are not adequate enough because they have a time window of decay, which I believe can be used to determine a random series of numbers in time. So my solution overall is to have create a mesh topology that resolves a system, which what the insurance should do on the fly. So, but it's getting hard to do because it's on the fly. So, it's not hard to do. It's just that the Cloudflare lava lamps are configured in a way that they are too. If you can calculate, if you know the exact position of a lava lamp, the randomness is not at a specific interval in time. You have a pseudo random number generated. I can use that number to attack the whole Cloudflare network in the real, not attack it, but not attack it. But I don't want to make claims here. You want to basically, as an agreement, you want to take the look at the line level coordinate system. Look at the position of the lava lamps, which are the random generated seeds of the system, and there's a decay window of the lamp because there's no GPS bound system. So you have to have the lava lamps facing you, and by computationally observing the lava lamps, you know that there's a time interval in space that allows for you to time out to perform some kind of attack to decide to operate from a attack vector. in the space of lava lamps, because lava lamps are just stacked geometrically and they have no connection to the hyperspace because they're just used to generate numbers. They're not cryptographically secure themselves because the mesh topology is not an operating system, they're linear facing systems. Because you have like what I believe to be 4x4. So if you take example, a 4x3 lava lamp, you have 12 lava lamps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 lava lamps. And by 4x3, you have 4 in a row, 3 in a column, which basically are 4x3 lava lamps. So by the time you observe, by the time you take a measurement of one of them, let's say you have row 2, column 1. Column 1, you have the second row of the second column, a random number. Listen, you take the second row of the first column. You have the lava lamp here, but this lava lamp is a geometry kind of normal sequence, but it's not part of a mesh topology. There's no part of a mesh topology. Definitely part of a mesh topology because this random number here, generally, is not pseudo. It's not linked to. It's not resolving with a direct acyclic graph. The numbers, if you get number, cryptography see the number via CRNG, cryptography random number generator. If you have the position of the data, the position of this which is basically longitude on the grid, and you put this number in a. So if you take the latitude and the longitudinal latitude, which is basically the y, if you take don't say, basically this upper line was just one pseudo random number generator. Second one. Second to one, the row to the column, row 2, column 1. If you take a random row, you see they're all divergent. You want a convergence. You want a divergence, but you want you want to have these numbers be randomly generated, yes, but you don't want to. We want them to want to start when one stops. Like when they want them to, you want an overlapping series or sequence. You want an overlapping sequence. So, for example, you can have this lava lamp generate a number 3218. 3218, and then this number is given a timestamp. It's a metadata. I'm framing it as a mesh topology. So you're gonna have a system of global position, basically this mesh topology is not hyperspace because it's not in a grid. This is not in a grid. It's on a grid, and it's not in a hyperspace. It's not like a 3D object. So basically the if it's a hyperspace, you go a better configuration that can't be timed out, easily because it's usually in a cube formation or where everything's a peer-to-peer network, and basically because it comes from the real world, you have to preserve the real world properties of the geometric properties that give you that cryptography framework. Unless you just want to project verify a 2D artifact, which is like a video file in real time. This really will work. But it's gonna have a system of explaining, because basically you want to take the 4x3 Namdi, 4x3, and make it a star or some kind of shape or topology, or like a stop pit, like a rig, like something like topological. So you have some space that is operating in, and that space is in between the lava lamps. So when you take a measurement of that region, you have no window to issue a tag vector because it's not a projection of the random continuum number. It's literally a transformation. Yes, you can't go through any arbitration which you're call an attack vector. So the single verified state is what it's doing. It's doing because it's doing in real time, and it's a geometric lattice. there's an order to the operation of any kind of partial subset of the mesh topology or the peer-to-peer topology, which is the algorithm of the lava lamps itself, based in space time, 3D space, in R3. So it's not it's not it's gonna be gonna be basically gonna for anything that's moving in the air, has to be what has to take in account of the real world noise. It's not like basically it's what Philip of Gold call a hyperspace, and hyperspace is like literally the space it operates in hyperspace, like the space between the wire connection and the wire connection, which is two ways to connect. So if you're only using wire connection, how can you ensure that if you're it's like so it's like this. If you have a wireless connection, how can you ensure a wired connection doesn't it's not like using as a attack vector to infiltrate servers? Because if you have a wireless connection, you can have a wire read information and then transform that information into a connection. You know, I'm saying. So that's what I'm saying. The goal of this is to explore how this can be used in the 3D space on a hyperspace. So we call it hyperspace. So it's a 3D environment that projects the cryptographic seed. You gotta have you can verify any kind of artifact in real time. So basically, if my robot is moving across the Earth, it's so water sensitive. That position is in any kind of image via linkable, then executable images outputted, can be verified in real time as they get transformed. As because you get a coordinate for that position in real time, and it maps onto the image in real time. You get again. So for every frame by frame of the video codec or the audio codec, you have a timestamp and a cryptographic random number generator, a SHA-256 digest for it, but they work in kind of the increment of time. So the delta minus 1 0 or 1, which is the quadratic formula for the discriminant for quadratic formula. So I'm gonna try to process that today. But that's how it works. It's NSIGII Verify is an on-the-fly verification system, which uses again topology via nearest neighbor algorithms such as KNN clustering, to map out geometric, map out where something is in real time, in space and time, via basically choosing based on nearest neighbor, which is the edge clustering too. So so basically if you do every frame has a correlation. This will happen at this time because the linkable and then is what's used to verify a system, used to dictate the motion, what's happening in the system. Thank you for watching this video. Verification.